All right, so today starts section 14.3. We have quotient of powers property. Somehow in the transfer of the notes, it did leave off one of the examples, so we'll have two problems that we write into our notes today, but everything else is in your handout. One of the main concepts that you need to know, and we just kind of touched on that, is my rule for quotient of powers. When dividing powers with the same base, I subtract the exponents. If it's different bases, this rule does not apply. So in example 1, that's what you see. You see a common base, all right? In each of these problems, you see the common base. So when that happens, you can write the common base. So on the first problem, it would be a 2. And here's the order makes all the difference. And you'll see when we start 14.4 why the order is really, really important in quotient of powers. You subtract the numerator minus the denominator. Okay, the numerator minus the denominator. And unless it says to write your answer as a power, which there... I need to look back in the textbook, but I don't remember what the instructions were here. The instructions will either say to simplify it, and then could I simplify 2 squared? Absolutely, to 4. Or it will say write your answer as a power. It will specifically say that. So you will know which way you're supposed to write your answer, okay? Now let's go to the next step down. The next one, -7. So we see that -7 is our common base. And what would I write in my exponents? What is being subtracted? Go ahead and tell me, everybody together. 9 minus 3. It's the numerator minus the denominator. So this is -7 to the 6th power. Now, if I were to evaluate this, that's like going to be a really, really, really big number. So I'm not going to worry about that. But again, on your homework instructions, on a quiz or a test, I will be very specific about if I say simplify and I don't say anything about writing your answer as a power, you need to simplify it all the way. Okay? But it wouldn't be a really big number like that. Okay? All right. I want you to try the right column now. Go ahead and try to simplify both of those all the way. Go ahead and simplify them. All right, so for h, what is h going to be, guys? H to the first power or just h. And then what about 4.2?
4.2 to the first power.
4.2 to the first power or just 4.2. All right, either one would be fine. You're not going to get a deduction either way. All right, so you can either put the understood one as your exponent or leave it off. Any questions on example 1? Okay. All right, so in example 2, now we see a combination of our properties. We actually see in parts of our fraction something that can be simplified. We have to do that first before we can simplify the fraction. So 3 to the 4th power times 3 to the 2nd power, because it's multiplication, what do I do to my exponents? What do I do? I need to add my exponents. Make sure you're paying attention. Okay? So when it's multiplication, I add my exponents, and now I rewrite my fraction. So this is a step that I want to see on your homework. You don't have to show me the addition, but you need to show me now what is your simplified fraction. And now, what are you going to do? 3 to the 6th power minus 3, which is 3 to the 3rd power. Okay? I want you to try the x's. Go ahead and try the x's. Do that one on your own. Okay, so I do want to see this though. Okay? X to the 4th times x to the 7th is what? X to the 11th power over x to the 5th power. I do want to see that part. Okay? Just asking about showing work. This is like the bare minimum. Now, we can do 11 minus 5. What's 11 minus 5? All right, 6. So this is x to the 6th power. All right. And Zach, going back to your question about showing work, when we do 14.4 and it's negative exponents, it gets pretty confusing. And so in 14.4, I'm going to be a little more strict on showing work because those negatives turn into double negatives, and we've got to kind of worry about more of that. But these are pretty simple, okay? We can use some mental math here. All right, go ahead and simplify the third one and reduce it, please. Write your answer as a power. Okay, so 2 to the 15th power, what do you get when you simplify the denominator? 2 to the 8th power, which when I subtract is 2 to the 7th power. How are we doing, guys? Okay, I want you to switch back to that second page of your 14.2 notes. It's got like most of that page is blank because I need you to write these two problems at the top. Okay, go ahead and write these two problems at the top down. Again, I really am not sure how this got left off the notes, so I apologize for that. But go ahead and write these two problems down because these are really important. It's not on your quiz tomorrow, but it is on your quiz on Monday. So it's, you know, kind of the more complicated side of Quotient of Powers. There's a little bit more going on. Okay, so here's my suggestion to you. There's actually a couple ways to do this. I could simplify across and then simplify up and down, but my suggestion to you would be simplify the first fraction, simplify the second fraction, and then multiply them together. So on the first fraction, this would be the common base of -4, and you would do 9 minus 5, right? What's 9 minus 5?
4.
So this is -4 to the 4th power. Does everybody understand how my first fraction simplified down?
Yes.
Okay? So what would your second fraction simplify to?
-4 to the 6th power.
Okay, -4. And remember, we are multiplying these. That's really important so I can use my product of powers. Okay, so because I have the common base, what can I do now to my exponents?
Subtract them.
Am I going to subtract them? I add them because it's multiplication. So this is now -4 to the 10th power. And make sure -4 is in parentheses. Okay? All right. Based on that, I want to see who can get the second one right. The P's. Okay? You know enough that you could figure this out. There's just a lot that could go wrong as far as there's a few mistakes that could be made here. Let's see who can get the answer. Okay, so P to the 9th over P squared, okay, times P to the 4th over P to the 1st. That's an understood one. Okay, so that becomes P to the 7th times P to the 3rd, which is P to the 10th power. Yes. All right. Okay, let's talk about these, all right? So these last two, what would my A fraction reduce to? A to the 4th times A to the 3rd, which equals A to the 7th. You see how fast that kind of goes now? All right, let's do the next one. -5 to the 2nd times -5 to the 4th power equals -5 to the 6th power. Good job, guys. All right. Okay, just a couple more things. Is your friend correct? If they're correct, you say yes. Is your friend usually correct? No. Okay. So your friend is probably wrong. If they're wrong, tell them what they did wrong in love. Get it? Okay, and then write the correct answer. Go ahead and fix this. Okay, why are they wrong?
Because they divide.
Yes, they're supposed to subtract. Okay, so I just kept it real brief, and my handwriting isn't the best on that. Okay, and what is the answer supposed to be? 6 to the 10th power. Okay, last one's your challenge question. Go ahead and simplify this, and we are done. This is not a challenge question. I mean, come on. I think they think the pi symbol is gonna like intimidate you.
No.
You don't even have to know the value for pi. You still just treat it the same way. Okay? You guys have your answers?
Yes.
All right. But it does look fancy, doesn't it? Okay. So, yes, pi to the 30th over pi to the 22nd equals pi to the 8th power. All right, that'll sum up section 14.3.